Those joining online, I believe you can all see my slides now. Can equally hear me. So yesterday we started looking at data structures, data structures in R, and we said you cannot do anything in R if you don't have the mastery of manipulating these data structures as in your arsenal. So you must, for you to analyze data in R, you must be able to play around with the various data structures, because the data can come in various formats, and depending on the task you want to do, you can decide to convert from one format to another, depending on the flexibility of the task that you want to perform. And that's why before we start doing anything data analysis, we have to understand the most relevant data structures. So yesterday we looked at strings and vectors. And in today's class, we'll continue from where we stopped. We hope that we'll finish the data structures today, so that by Friday, we'll start with the data analysis with the basic R, isn't it, before we now go to the advanced methods. So lists are other types of data structures, and from the name, I want to... From the name, you know, it's just a list of stuff. And similar to vectors with only one key difference. The key difference is that a vector can only contain elements of similar type, while a list can contain heterogeneous elements. Okay? Is it my... Okay. A vector can contain only elements of the same type. Even if you put heterogeneous elements, if it's a vector, going by the fact that vectors are error-friendly, it's an error-friendly language, it will forcibly convert one to the other, isn't it? Is that okay? For example, let me show you something. Let me create a list here. Sorry, a vector here containing, okay, so all of the elements are all numerical values, isn't it? And of course, if I index, let's say the second element, I get a 2. Let me modify this vector to contain an additional string. Let me call it Yusuf. Library. You know, I told you that vectors can only contain homogeneous elements, isn't it? So if it were another language like Python, it will raise an error. But because R tries to just translate, maybe it has it in mind. So it knows that for a vector, it can only contain homogeneous elements. So it will assume that you also want to represent the other numerical values as a string. Okay. So if you run this now and you call x1, you will see that x1 is not going to be 1 as a numerical value, but 1 as a what? As a string. It's clear, go? So vectors can only hold elements of the same type, and lists are another data structures in R that are similar to vectors, but can hold different types of data. So a list can be created using the list function. A list, we use list. A matrix, we use matrix. Data frame, you know, similar. So if you want to create a list in R, this is the function to use, list. And you can see that we can contain heterogeneous element, isn't it? The first element is a what? It's a string. The second is, the third is a vector, and then the fourth is a numerical value, isn't it? And the irony is that if you do this and you try to index one, it will appear as its streams. And if you try to extract 1, 2, 3, 4, it will remain at its 42. It's clever. It's clear. So as you can see, our list contains strings, numbers, and vectors. So we can access list elements similar to vectors. So we have a list X here that contains 4 elements: James, Bob. Try to access the third element: 1, 2, 3. 1, 2, 3. You have what? You have the vector, isn't it? So we use double square bracket to output the value of the element without its what? Its index, isn't it? This is just the line number, it's not the index, isn't it? You understand now? If you use one bracket, you're just saying, just give me the element, isn't it? But if you use single bracket, you are going to, it will give you both the index and the element. So a list can also contain a matrix or a function as its element. And lists are used in R to represent data sets, because typical data sets come in various formats, isn't it? If you have a list of students, you can have the column for age, which is a number. You can have a column for gender, which is a string. And then you can have a column for, let's say, what should be a vector be? Maybe favorite colors, isn't it? You can represent that as a vector. So when using named elements, an alternative to the double square bracket is to use the $sign. This one, you must understand this one. If you don't understand this one, just log out of this class or sign off and go home. Because throughout your data analysis task, this must be your friend. The $sign, isn't it? So it's an alternative to the double square bracket. And we all know what the double square bracket does. What does it do? It accesses a specific element from a data structure, isn't it? Without necessarily bothering itself with the index, isn't it? So look at this example. You have a list that contains elements James 42 and false, isn't it? If you want to access the name James, how do you do? From our previous knowledge, you say X double square bracket, then the name of that's the string holding the name, that's name, huh? So if you don't want to do that, you can simply use $sign. Isn't that elegant? As opposed to square bracket, just use $sign. So for example, we have, let's replicate it here. We have X, it's a list containing what? Name is equals to James. Then the age is equals to, let's say, 43. And then the gender is equals to male. And then the marital status. Marital marital status is true. Okay.
What the speaker?
Sorry. Gender. Okay. Sorry. Number. So it will not be a string there. True. True. Yeah. It's a Boolean. True. Okay. It's 1 greater than 0.5. It's true. So Boolean is true. True and false. It's what? True and false is what? True and false is what? It's false. Eh? True or false is what? True or false? True or false, and true or not false. What's the answer? So
false. It's false. Not false, not true.
So please call it for me. I will illustrate. Don't worry, I'll illustrate. It's okay. This guy, not false is what? Not false is true. And then not false is true. Then we have true or true. True. And then false and true. So this is true and true is true or true is true. True and false is false. And then false or true is true. False or true? No. And then false or true is true. And then not true is false. The answer is going to be false, isn't it? But of course, if I do like this and I say not that, because the entirety of here from here to here is false, and then not false is going to be true. So you have to learn how to play around with all of these things, please. Okay. So what you're saying here is that I have a list here, isn't it? If I want to get the names of James, okay, let me not violate in the grammar rules because it's a proper noun, James. So we have, if I want to print James, I will say James what? I can put 1 because it's the first index, or I can put name. And if I do that, I get what? I get James. It's clever. What's the difference of putting 1 bracket? It will give me James together with the index, isn't it? So if you do like this, it will give you the int plus the index as name. But if you're simply interested in the element, then you have to use double square bracket, isn't it? Yeah, so what we're saying is that an alternative to this guy, this double square bracket, is what? Is $. So that's $. What? In fact, R is smart. As you type the $, it will enlist all the available indices for you. And then you can just select the one you want. So, and if you do that, you have what? You have James.
Okay.
Hmm? That's the learning objective for this unit. But the dollar sign is an alternative syntax for accessing elements of a data structure in R, as opposed to using the double square bracket. So you did the second line. Yes, I commented it. I commented it. This is our first lesson now. I commented it, so it is useless. Even if you put no, it will not give you error because it has been what? It has been commented. It's clever.
But I have a question.
Okay.
If that's the case, it is one encompassing so why did it work? Since at least before there wasn't at least only vector.
It's a good question. I like your inquisitiveness. There are scenarios. There are scenarios in which, under no circumstance, you want to hold some list of numbers, and under no circumstance do you want any data type except the number. If you use a list, it will accept both numbers and non-numbers, isn't it? But if you strictly want numbers, then you use a vector. For example, if you're writing a program and you want to track the number of times maybe you want to track years, the specific years you traveled to Saudi Arabia. Maybe you traveled to Saudi often, and then you're just tracking the year in which you traveled. So let's say you traveled 5 times, and you want to denote that as a string, isn't it? So you can say my travel years, is equals to a list, right? So you can have 1990, and then 1995, then what? 2011, and 2022. If somebody enters another thing here, maybe last year, you don't want it. So it's better for you to use a vector. 2010. 20, just an example, okay, cool. 2010. I think it's clear now. As you analyze data, you come across several instances where you simply want your data to be of the same just use a vector, isn't it? There are some things in programming that till you die, you will not use them, isn't it? But maybe someone else would want to do something, but it has a specific requirement that the data structure should contain the same element. Then you have James and Milva. I want to combine them together and bring them out. James space Mill. How do I do that? I don't want to type it. I don't want to say print James Mill. I want you to pick up the James from the list and also the gender from the list. How do you do that?
You can use $sign.
Okay, let's do that. I'm listening. Very good.
Use not $sign as you did it.
Okay,
for the name, and then for the gender.
Okay, then
$sign for the gender.
$sign gender. Like this?
Yes.
You want to go?
I don't know.
Yeah, I want to go to give you error now because there's nothing happening here. I want to print James and then Mill. How do I do that? Yes. Okay, very good. It's a good one. Let's do methodological. Let's say A is equals to X number. No, I have forgotten one thing. I have removed. I just want to print James and Mill together combined, separated by space. Huh? Okay, A is X name. B is equals to X $sign gender. Paste. Please clap for this. Why? Because name is a string and gender is also a string. And he has remembered that if you want to combine two strings together, you can use the paste function. So because you've learned string last week and you learned list today, and tomorrow you learn matrix, and next tomorrow you learn data frame, it is your duty to combine this, and that, and
As data scientist.
to make up of all the words.
Yes.
So you just come here and say, okay, paste what? A, comma, B, and then that's all he has, James Mill. What if I want to print James is a male, and I want to also use this? What do I modify?
So what is the function of that place? I don't know.
They are correcting us back. Okay, Zuba, you've not said anything. Paste is a function that is used to concatenate strings. So you can just come here and say, set is equals to what? Is A, have you? Are you? Since I can also just add a space. No, it cannot. It cannot. It was something that I added it. This gives me but when you add the cell, then it now brings. Another question. Why am I asking this question? Just for you to have in your mind that it is your duty. Me, I'll just come and teach you. But if you have a problem, it is you that will crack your brain and say, okay, since I have learned this, okay, I want to double James' age. How do I do that programmatically?
I joined in the now synergy class. That's again.
Final was up to there. I don't know how the one why.
Please, this is what wants to doing, especially when you come next week. Me, I will not be wasting my time. I want to assume that you follow it. So I'll just explain and move. Okay.
Hello, sir. Sorry, somebody said
Somebody
something.
said, yeah. It's not, we can go ahead and ask the question.
Assalamu alaikum, sir.
Yeah, alaikum salam.
It's like your screen. We cannot see the screen anymore now, sir.
Somebody is, yeah, alaikum salam.
Yes, sir. We can see it now.
Sorry, am I answering the question? Sorry, am I answering the question? Yeah, of course I am. Okay. I said I want to double. I want to print out James age, but double it. So it's very simple. Right? I can just come and say X $, X $, age, right? Isn't it? This will give me 43, right? And then I can multiply by what? By 2, isn't it? And then I can print out that, isn't it? That'll be 86. Cool. Possible in Python is because you can use plus. You can say A in string plus A in string. That would be AA, isn't it? So it's not possible here. Who can write a program that will check if the person is? You want to write a program that checks whether that checks the gender of the applicant. If the applicant is a male, then you allow him entry. Otherwise, you say he's not allowed. But if the applicant is a female, I have this guy now, and I want to write a simple code that checks if the applicant is a male or female, isn't it? So what do? You simply come here and say what? If, open bracket, what? X $, X $, gender is equals to what? Okay. Equals to male, but then you can come here and see what? Print what? Please enter, isn't it? And then else you can have what? Sorry, this premise is strictly for what? But the main knowledge here is, can you see that? Because S dot gender is either male or female, isn't it? So it checks this. If it is male, it means it will print please enter. Right? If it's female, so if you run this now, what do you have? It says please enter. Right? But if this is Jamila and I say female, isn't it? And I run this, it says, sorry, this print is strictly for male. But if I want to, if the code I'm writing is only for the married, how will I do that? Yeah, if this code will only check if you are married or not. So what will I put here? What will I put here? If you give me the answer, I'll give you something. What will happen here? Okay, X $, M status. True or false. So like this now, if I run this code now like this, what will happen? Will it print please enter, or sorry, this premise is really for married married couple? Is it a tautology? Is it for couples? If I run this code now, just look at the code. Forget about the semantic. What will happen here? It will print please enter. Because remember what's coming here. This is the condition. And when we treated if statement, we said what is inside that bracket must either be true or false. If it is true, so because this guy is true, so it will print please enter. But if this guy is false, it says what? It's clear, huh? Okay. So I think we've treated all this. If you have a list, you can D, yes. X age is the same as this, isn't it? What's this? We are simply assigning whatever is inside age to what? To X. If age is not defined earlier, it will return to error, it will give you error. If you put age here, it will just print out the age. This will give you the age together with the index. And then here will only give you the specific age. So these are some. If you have two lists, you can combine them using the vector operation, and then they'll appear together. Is that okay? And then if you want to convert a list to a vector, you can do what we call onList. Some operations require that the elements are homogeneous. And we know homogeneity is only found in vectors, isn't it? And if you have a list that contains some elements and you want to perform some operation that requires homogeneity, then you have to convert them to a vector. And do it. Somebody is asking for online. Okay. Okay. Is everything okay now? Yeah. Okay. Sorry, I don't understand. Must we highlight before we execute it? Because most of our, yeah, please. In R, if you're running code in R Studio, you have to highlight the text that you want to run before you run it. Thank you. Okay. So if you want to convert to a vector, you have to put, you have to unlist it. Then it becomes a vector. Then you do whatever you want to do. For example, you can sort, isn't it? Sort means you want to present them in from, yeah, yes. Mean, you can take their mean, etc. So we also have matrix. A matrix is a two-dimensional data set with rows and columns. It is similar to a vector, but has an additional dimension. You know, a vector only has one dimension, no? It's just, but a matrix has additional dimension. It has two dimensions. It has rows and columns. Yes. So a matrix can be created with the matrix function, specifying the rows and the columns using the n row and the n column parameters. So for example, if you have this a matrix that's obtained from a vector 1, 2, 3, 4, 5, 6, and then we want to make it to have 2 rows and then what? 3 columns, isn't it? Okay. So let's say X is a matrix. Okay. And what do we want for the matrix? It's a vector containing the numbers 1, 2, 3, 4, 5, and 6. And then the number of rows should be the number of rows are 2, and then the n column are what? Are 3. And then we can now come here and say print what? So what do you notice? If we simply printed, I can make this 1, 2, 3, 4, 5. Okay. Let me just make it 6. If you print 1 to 6, this is what you get: 1, 2, 3, 4, 5, 6. But if you want to convert this to a matrix that has 2 rows and 3 columns, so you have 2 by 3 column, 2 by 3 matrix. And how do we populate the matrix? We populate the matrix column wise. Okay, so if we have 1, 2, 3, 4, 5, 6. This 1, we have 2 rows, no? 1, 2, 3, 4, 5, 6. Column wise. It's clear, go? Sorry.
Specified that you want it to be 2. That's the reason why.
No. That's the rule. Irregardless of what number of rows and number of columns you have, as it is populating it is populated column wise.
Assuming you say 4, that means going to 3 lines. Sorry.
Okay, if you come and put here, but then if you have 6 elements, if you do learn the length of this guy, okay, the length of thanks. The length of this guy is what? Is 6. So the number of rows and the number of columns, mathematically, when you multiply the number of rows and the number of columns, it should be equal to the length of the vector. Huh? It's not. Yeah, who asked you to use cat? How can you try? Cat is just for printing now. The syntax is matrix. Okay, where you print here? Okay. 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 Just use print. Or you can just call X alone. Okay? You can just call the X itself without even printing anything with it. But if you do get X going to, cat, the cat does not like using all this index, right? So that's why it just gives you the elements, isn't it? But in this case, okay. what we're saying is that the way it populates the vector is column-wise. 1, 2, 3, 4, 5, 6. If I have 3 here, what will happen? It will not be compatible, but because 3 times 3 will not be enough, isn't it? So as you can see, it added 3 times 3 is what? 9. So it knows that this guy will not be enough to complete the matrix. So it now, after 1, 2, 3, 4, 5, 6. Say down from Google, started from the beginning. So if you have, let's say 6, okay, let me say 1 here, and then 6 here. So you know, we have the vector is 1, 2, 3, 4, 5, 6. And we specify 6 rows. 6 rows. 1, 2, 3, 4, 5, 6. And then 1 column. That's why you do 1, 2, 3, 4, 5, 6. So let's say we have n rows 2 and then n calls to 3. So we're going to have 3 and then 2 columns. So the population will be 1, 2, 3, and already you have to finish here before you go to the next. What if I just supply in the n row and refuse to put the n column? What happens? Yeah, no, it is smart. Yeah, it knows that, okay, since the length of your vector is 6 and you supplied in 3 rows, it knows that automatically there has to be 2 columns. So if you do that, it's going to be normal.
Situations I wanted to be that let's complete the first row before going to second. Not the way it's arranged that 1, 2, 3, 4. Populating it according to colors. No, I want it 1, 2, 3, then 4, 5, 6.
There are several ways. There's what you call transpose in matrix. Bakana is one number is the one we have, what?
Yes.
It is 1, 2, 3, 4, 5, 6.
Yes.
You can just come here and see print the transpose of X, okay? And it would do it for you in that direction. Is that okay? So in transpose, the rows becomes the columns and the columns becomes the rows. So like I mentioned, Kuma, if you supply in something that is larger than the matrix, maybe because let me say 5 by 3. What will happen? So it will do 1, 2, 3, 4, 5, then 6, 7, 8. Sorry, 1, 2, 3, 4, 5, then 6, 1, 2, 3, 4, 5. To continue until it does 5 rows and 3 columns, isn't it? So it will do 1, 2, 3, 4, 5, 6, 1, 2, like that. So how do we index it? Okay, as you can see, we give a vector as the data and create matrix with 2 rows and 3 columns. The data is filled column-wise by default, just like a vector, and all elements have to be of the same type. You can skip one of the parameters and it will be automatically populated from the length of the data. This is an example. You can also access elements of the matrix. And if you're indexing now, you know, for vectors, you only index by the index. And the index is just a number, either 1, 2, 3, 4. But for a matrix now, there is a row and there is a column. So if you want to give the full address, you have to give the full address of both the rows and the columns, isn't it? For example, here, look at this now. If I want to bring this guy, 2. 2 is in the 3rd row, 2nd column. So I'll just come and say X what? 3rd row, 2nd column, and that will be what? That will be 2. Yeah? Sir? Yeah, it obeys the index, rows and columns. Row, comma, column, row, comma, column. So if I want to get 5, it will be what? 1, comma 3, isn't it? It will be 1, comma 3. If I want to get all the elements in the first row, sorry, all the columns in the first row, I want to get all the rows. I want to get this guy. I want to get 165. You can just supply in 1 alone and you refuse to put the column and it will give you, you understand? If I want to get 1 now, 3 comma, if I want to get, let's say the last column. The last column is, no, it's this one, no, look at it. This X, the last column, it will just be nothing, comma 3, isn't it? So it will be X, nothing, comma 3. Okay, let me do something like this. Let me say X is equals to, okay, let me say Y is equals to 1 to 24. Then okay, 64. It's clear, huh? If I run this now, Y is a number between 1 to 24, and I want it to be placed in what? In 6 rows. 6 rows from Akaway. It means there will be 4 columns in Uncle, but I can just specify. Then n call to be equals to what? 4, but and if I print matrix now, it will be this, but I want to print only these guys. Doesn't it? I want to print only this. I want to print only this guy. Eh? Eh? Should be what? Hmm? Daddy, I want to index only 4, 10, 5, 11. 5, 11. Yes.
Is it the same arrangement or just anything?
No, I only want to get 4, 10, 5, 11 as my answer, and I want to.
You just index 4 and 10.
Okay. X would be simple. Which row do I want to get? Which row do I want to get? I want to get rows 4 to 5. I want to get rows 4 to 5, comma, the index for the column for column 1 and 2. Indeed. And then if you do that, it will give you 4, 10, 5, 11. It's clear. Yes. Let me delete this. Yes, sir.
For example, this one is delta, only the same element. For example, if you want to make it like 2A, 7B, C, combine this. Is it the same
You know, unfortunately, matrices also contain only similar elements. Let me come again. This is y is 1 to 24. Yeah, you know, if you run this now, and if you call y, it's going to be 1 to 24. I now want to convert this y to a matrix that has 6 rows and 4 columns, isn't it? So the rules, it will be 1, 2, 3, 4, 5, 6. You know, it's populated column wise. 1, 2, 3, 4, 5, 6, like that. So if you do that, this is what you get. You have 1, 2, 3, 4, 5, 6, 7, 8, like that. So I now said I want to access this 4, 10, 5, 11. The rule of indexing says you index a matrix using its full address, the row and the column. If I want to get 9, 9 is in what row? Oh, I'm talking Hajia. Third. Column? Second. So I get 9 here. In the same manner, if I want to get 4, 10, 5, 11, I ask myself, 4, 10, 5, 11 covers which row? 4 to 5, isn't it? So it 4 to 5, and then the columns are what? 1 and 2. 1 to 2. And then that's why I got 4, 10, 5, 11. Okay? If you want what? If you want, don't do me Tembe forever. Don't do Tembe to me. Yeah? 16 and it's simple now. It will be what? It will be x. It will be 4, comma, no, 16 and 20. It will be 3 to 4. What? 3 to 4. 3 to 4. Oh? Okay. Sorry. That's it. 16 and 20 go. It will be 4, 3 to 4. Let's go back to our class. So if you ignore the first element, you are telling R that I want everything. Abi? Yeah, if you say X nothing, comma 1, you are saying all the rows and of the first column, isn't it? And you can also change a value, isn't it? Maybe X here. If I want to convert this guy to 170, what will happen? It will be X. It will be X what? 4,3 equals to 170. Right? And if you now call X, you see that it has now become 170. So this transpose, it converts the rows to columns, isn't it? For example, here, if I do print the transpose of X, you see, there were 3 columns earlier. The columns became the rows. The transpose simply converts the rows to columns and columns to rows. For example, X is what? This X. If I want have 1, 2, 3, 4, 5, 6. The transpose of this guy is for, I don't want to, you carry this guy and then you divide it there. So you have 1, 2, 3, 4, 5, 6. For example, if you have x is equals to 1 to 6, okay, and then you do y is equals to matrix x, 2 rows, but n rows equals to 2. So your y is 1, 1, 2, 3, 4, 5, 6. If you do the transpose of y now, so it becomes 1, 3, 5, 2, 4. It's like you are too fast for some of us that are absolutely beginner here. What? So this is a quiz for us to. Ajia, this quiz is for you. So we have 8025. The number of columns is what? So it means the number of rows is what? Because the elements, the length is 4. So 2 times 2 is 4. And we know they are usually populated column-wise. So we have 8. We have 8. Where's the okay. We have 8, 0, 2, and then 5, isn't it? And then if we take the transpose, it's going to be what? It will be 8, 2, 0, 5. And then the second, we want to get the second row of the first column. So of the first column, that's 2, go. The answer is 2. It's clear, go?
Yes.
So data, we've seen how to store data in vectors, lists, and matrices. They all have similar ways of accessing, modifying, and adding elements. The major difference between them is the structure and type of data they can store. So vectors store elements of the same type using 1 dimension. Matrices are like vectors and have 2 dimensions. Yeah. And then lists are similar to vectors and allow you to store different types of elements. So the most commonly used data comes in the form of table, and each column can be different types. What if we want to store different types of elements in 2 dimensions? You know, for the matrix, we can store data in 2 dimensions, but all of them must be of the same type. But this is not typical of our practical data. Data comes in varying formats: gender, state of origin, age, scores, etc., isn't it? So you can have decimal numbers, strings, Boolean, true or false, etc. So the most convenient way of storing data of that heterogeneous nature in a two-dimensional way is what we call a data frame. And this is the heart of any data analysis task in R. If you don't understand how to manipulate data frame, then you're on your own. So that's where the most important data structure of R comes in. It's called a data frame. So what is it? A data frame is a table where each column has a name and can contain any type of data. Each column must contain the same number of data items, and we can create a data frame. For example, let's say we have this data. We have an X to be a data frame. And the first column is the ID, isn't it? 1, 2. And then the second column is name. And then the third column is what? So just the same we do for, of course, the age can be represented as a vector, isn't it? Since depending on the number of IDs we have, isn't it? So let's have an example, isn't it? So we have ID, name, and age. Go. Maybe I'll keep this data frame. Let's say X is equals to the syntax is data dot what? Dot frame. And then the first one is what? Let's say ID or serial number, isn't it? Serial number. Serial number is equals to, let me make it 10, so that we can have a more comprehensive analysis. 1 to 10. Then what's the next one? After name, names go. Names go. The names should be, yes, let me use, let me have a vector containing some names. Let me start with Aliyu. No, let's go. B, Bello. C, Charles. Charlie. Then D, David. 1, 2, 3, 4, 5. And then what again? E. E. Okay. Esther. A, B, C, D, E, F. So let's make it 5 going. 1 to 5. It's okay, but. And then the what again? And then the age. And then the age is what? The age is also a vector. Let me say Aliyu should be 31. Bello should be 22. Charlie should be 27. And David should be 45. And then Esther should be 19. Is that okay? So this is my data frame now. I can just come here and print X. So this is my simple data frame. Remember, if I have more names, I will have more friends. Please and please, if you've not been paying attention to this class, I want to advise that you give special attention to this, because whatever we'll be doing till the end of this class will be based on this. Any data that comes to you will be in this nature. isn't it? And whatever you want to do on the data would be based on this nature that we have. If the data is not in this format, it is your duty. It is your duty to first of all convert it to this data, to this format. Then you continue to do whatever we've been doing. Each and every one of us can create a data frame. Who cannot create a data frame? Yeah. Everyone here can create a data frame, isn't it? Good. Yeah? Okay. The syntax is, a data frame is just a table that has rows and columns. Okay? It's a table that has rows and columns. And the column should have the same size, isn't it? So if the first column is the serial number that has 5 elements, the names should also have 5 names. The age should have, there should be 5 ages, etc., isn't it? And how do you do that? The syntax is X is equals to, then data frame is a function, then open bracket. Then what do you want to be the first column? The first column should have a header, serial number, and then the element should be what? Numbers 1 to 5. The names, the second column should be what? Should be names with elements Aliyu, Bello, Charlie, David, and what? And Esther. The third column should be age, and it should have what? This particular, if I want to add another column, what do I do? Let's say gender. It will be, let's create another, and then it will be a vector containing what? Ali should be a male, yeah? Bello is also a male. Charlie is also a male. David is also male. Sorry. David is also a male. And then finally, Esther is what? It's a female. And if you run this code, you'll see that this is our new data frame. Okay. Okay. Doctor, is it clear now? Yes. If you, whatever we do based on this, whatever we'll be doing in the future, it will also be based on this. If I give you any data, it's something like this. Maybe JAM applicants, or you will see a list, Amade to be larger than this one. Maybe there'll be 1,000 names. And then maybe there'll be 8 columns. Maybe serial number, name, gender, posture, local government, kaza, 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 containing several things. But if you understand this, whatever we learn here is what we extend to that. Is that okay? The thing about programming is that whatever you can do to 5, you can do to 5 million, isn't it? Go back again. If I learn how to print number 1 to 5, if I want to print 1 to 50, but if I want to print 1 to 5,000, I will just print this. So whatever you want to do, once you learn how to do it on small, you can extend it on big. So don't freak out. The data frame. Let's start talking like data scientists, please. The data frame.
From the slides that the items has to be the same with the names. But now just add another column for gender. So does that mean that it's not the column size cannot be affected, can always be extended, increased,
Mhm.
but the row size.
Even the row can be extended now. Where I said is that if if I remove this F now and I run the code, what happens? I see error. Why? Because each column there are 5 names, but the gender here is for 5 persons. It's for 4 persons. 1, 2, 3, 4, 5. So if I make it 5, if I run the code, it's fine. If I want to make it 6, what will I do? I'll just come here and make this to be, just make this to be 6, go, Abi, and then I can control Y, and I can add I can add Sweetie here, isn't it? I can add Sweetie here. Okay, 6, and I add another name here, and then Sweetie is an old man, he's 66, and then it's also a male. Is it clear? Arashiba?
So my question
Mm.
is based on from this one. Now let's assume you wanted a blank space for a comment, which the name should not be written like R.
We want
A blank space for making a comment.
for making.
Let's assume that I want to make a comment. Maybe I'll make a sign or I tick that this one is accepted or this one is rejected. I wanted all of them.
A column, but that
And now
contains nothing.
Right?
That contains nothing.
Either a column or a row that contains
Nothing.
space on my sheets.
Why not? You can have it now. Yes. Maybe you can let me come here. Let me add another row. Let me say go. Let me say remark, isn't it? Let me say a remark, isn't it? The remark, it is you that after printing that you want to write something on the paper, huh? And so you can just come here and say equals to what? Remark, and then it's equals to a vector containing yeah, space, the number of space that you want. How many do you have? So we have 1, 2, 3, 4, 5, 6. Can even come and open it here. Isn't it? And if I run this, I have a remark, and then there'll be a column for remark, but there'll be nothing there. It's clear now.
You have to create it for it.
No. If you are importing a data, if you are creating a custom data like this, you have to ensure that everything is there. But if you are importing a data, you can import a data that has missing values. Yeah. So even there, what you have is not a number, isn't it? But it will appear blank, isn't it? You have what you call NA, or not a number, or nothing, you know. So there are ways in which you can handle that when you come to Big 4. Let's continue. Okay.
So the value that will have to be putting it.
No. There is a way in which you can import data. We are going to look at it. You can import it, even if it is 1 million entries, you import it. Only that you cannot visualize 1 million data here. There is a way in which you can get maybe the first 10 or the first 20. The role of programming is to programmatically manipulate something. So you can just pick up the first 10 and then do something on it. If it works fine, then you extend to the entire length of the data, and then you are guaranteed that nothing happens. It's clear? Yes, ma'am.
Okay.